Our daily life is completely mixed with uses of plastic. Can you imagine a single day without using a plastic object? It's almost impossible. Yes, from brush time to bedtime, we are using different plastic objects or different polymer objects in different forms. So today our topic is plastic is good or bad to environment? And also this video going to explain the introduction of polymers. I am Dr. G. Srinivas Rao. Thank you for watching my videos. Please subscribe if you like my videos. Polymers can be converted into plastics, fibers, rubbers in different forms. These objects we are using every day. Can you survive a day without plastic? Yes, from wake up time to again bedtime, we are running on the plastic objects. So if you see right now, if you see around you, you definitely will find a plastic object which is used by you. Do you know over 1 trillion plastic bags are using every year worldwide? In that, only 1% of plastic bags are going to recycling process. So each plastic bags produces 10% of waste on it. And every minute worldwide 1 million plastic bags are using. Because of these plastic bags, 1 million birds and 100,000 marine animals are dying because of these plastic objects. A single plastic bag can take up to thousands of years to degrade into landfill. So these are the real facts of the plastics. So is the plastic is good or bad to the environment? After knowing these facts, you can definitely say it is a bad to the environment. Yes, plastic versus environment. Plastic is destroying the environment. But in another perspective, if you observe, plastic is a very good invention by the chemist. Just imagine if they don't invent the plastic object, we still depending on the paper objects. Papers are coming from the trees. So here plastic is a good, but the way of using is not a good. So humans are exploitation the usage of plastic. Just imagine still we are using paper instead of plastic. So how many trees are required to provide this much of paper bags or paper objects? So up to now we have to use all trees on the earth surface. If we don't have trees, our environmental totally will be changed and we are unable to survive on this planet. So definitely plastic is a good object, but humans are not using in a proper way. So when we are went to the market, we will bring vegetables on a plastic bag. When we came to home, we just throw the plastic bag outside just like a banana peel. But banana peel can destroy or degradable within weeks, but not plastic object. It takes years, many years it takes to degrade. So that's creating a problem. So if you observe the plastic was paper, plastic bags were invented to save the planet. Paper made from trees and production of paper from trees consumes much energy. It is a very difficult process also. Relatively small amount of energy and raw materials are needed to make plastic bags. Using of plastic instead of paper means saving the trees on the earth, that is protecting the globe. That's why plastic is a very good innovation by the chem. So let's come to the what is polymers. So polymer is a word from Greek. Poly means many, mers means parts. Many parts can make the polymer. So polymers are macromolecules which are formed by combining of large number of small units. Those are called monomers. When monomers combine each other by connecting with covalent bonds, then a large molecule is produced. That large macromolecule is called polymer, and this process is called polymerization. Starting units are called monomers. Monomers connected with the covalent bonds. The bonds present in the polymerization is covalent bonds. If you observe here the green balls, these are the single monomer units. When they are involved in the polymerization process, they connected with the covalent bond. So there is a covalent bond between the monomers and forms a long chain. So this chain is called polymer. So this is called polymer. Examples are polyethylene, polystyrene, polyvinyl chloride, backlight. Like that we can say so many polymers we are using everyday life. So polymerization. Again we can change the definition. It will come the polymerization. Polymerization means it is a process converting the small organic molecules into high molecular weight molecules either by addition or condensation reaction. I will explain what is addition and what is condensation reaction. Either by addition or condensation reaction, these monomers combine each other and forms a large object. This process is called polymerization. The small molecules is called monomers and large object is called polymers. So number of, for example, if you take here number of ethylene molecule. So if you take ethene molecules here, number of ethene molecule taking and involved in polymerization forms a polyethylene. So polyethene. So you can see here polyethene molecule formed by making covalent bonds between the each monomer. So polymerization process. But my question is, which monomer involved in polymerization? What is the criteria for monomer to involve in polymerization? Every monomer can involve in polymerization? Definitely not. So what is the criteria? That is called functionality. Functionality means the number of active bonding sites on the monomer which responsibility to polymerization process is known as functionality. Who responsible to polymerization process is known as functionality. For example, if you observe the methane CH4, CH4 doesn't produces bonding sites, so it doesn't involve the polymerization. So CH4 means carbon having 4 sigma bonds with the hydrogen atoms. So these sigma bonds are very stable. They doesn't involve in the polymerization process. They doesn't break during the polymerization process. The CH4 molecule doesn't interact with the another CH4 molecule. That's why this methane doesn't involve in the polymerization process. Okay, so if you observe the ethane also having only sigma bonds. It is also very stable. It is also not interact with the other ethane molecule and doesn't form the polyethane. If you take ethene molecule CH2 double bond CH2, if you observe here there is a double bond, sigma bond is there. Sigma bond is weaker than the pi bond. When you apply some heat or catalyst or photolight, it involved in the polymerization process. This ethylene molecule can interact with the another ethylene molecule, like that, so on. So many number of ethylene molecules involved in polymerization, they forms a polyethylene. Just like acetylene also having two double bonds. That means two pi bonds. So this one of the bond breaks and it involved in the polymerization process. So who having the double bond or triple bond, they can act as a functional groups. They can responsible for the polymerization process. But CH4 having only sigma bond, that sigma bond is not responsible for polymerization. So there is no functionality in CH4 methane. That's why that doesn't involve in the polymerization process. So next one, how many bonding sites required for a monomer to involve in polymerization? So bonding sites are required, but how many bonding sites are required for each monomer? If you observe the diagram here, one person using his one hand with the another person with having a one hand. So they are not using their second hand. So the just bonding is ended with these two persons only. That is mean it's a dimer. He is one of the one monomer and he is one monomer. When they are making bonds with their only one hands, okay, here bonding is closed by the making dimer. They are not using the second hand. That means only they have only one bonding site. They are making one single bond with the others and the process is end up with the dimer. If you observe the downside, So each person using their two hands and making bonds continuously and forms a large molecules. These large molecules is called polymers. So when they are using two hands, that means each monomer having two active sites. When two active sites present on one monomer, then they can involve in polymerization. So there is a two conditions. One is they should have a bonding sites. Those are called functionality. The functionality also should be two, two or more than two functional centers is there. Then only polymerization takes place. Monomer should bifunctional to involve in polymerization. At least bifunctional. If having more than bifunctional, also involved in polymerization. So condition is at least two functional groups should be present in the monomer. Then only a monomer involved in polymerization process. Okay, just now I told ethene are having two bonding sites. How ethene having two bonding sites? They have only one pi bond. Then how it creates the two active centers? For example, if you observe the ethene in homolytic cleavage means so equally if you break the bond, so there is a two radicals present on the ethene molecule. These two electrons of the bond is shared by these two atoms. So there is a two electrons is there. If you observe the another ethene molecule CH2 double bond CH2, sorry, CH2 single bond CH2, they also form radicals. So again the bond is rearranged here. That means so double bond is broken within the molecule, and it is also having a radical. Now this radical and this radical forms a bond like that. If you observe the monomers ethene having two active center, this one and this one, so that's why it can involve in the polymerization process. Or otherwise, if the ethylene involved in the heterolytic cleavage, that means accepting of electron by one atom. Okay, so the atom which is accepting electron having a negative charge, and atom which loses electrons is having a positive charge. Now positive and negative ions are formed in the heterolytic cleavage. They also interact with the another negative opposite ions of the same molecules, so they interact in the polymerization process and produces the polymers. So double bonds can create two bonding sites during polymerization process. That's why ethene has bifunctional monomers. It can involve in the polymerization process. So next question is only double and triple bonds having molecules involved in polymerization? Definitely not. So criteria for formulation is at least two bonding sites on monomer. These bonding sites, apart from the double bond and triple bonds, can also make by using functional groups like OH, COH, NH2, COCl. That means alcohol groups, carboxylic acid groups, amine groups, acyl groups. So, but the condition is one monomer should have two functional groups, just like this. If you observe the glycol, so here this is CH2 double CH2 single bond CH2, it having left side one OH group and right side one OH group. That means this monomer having two functional groups, just like COH, two COH groups on the CH2 molecule and two NH2 groups on the one CH2 molecule. So like that every monomer should have two functional groups, then also it can involve in the polymerization process. So now the condition is, so example for the monomers are any molecule which having double bond or triple bond, first one, and second one is if the monomer having two functional groups on it, it is also eligible to involve in polymerization process. Okay. So, and next one is degree of polymerization. So the number of repeating units in a polymer chain is called degree of polymerization. For example, so some you added number of ethylene molecule in a beaker and involved in a polymerization process. Finally, you got a long chain molecule. If you count how many ethylene molecule present in the polymer, the number is called degree of polymerization. For example, 1000 monomers involved in polymerization process and forms a polymer. If you count the how many repeating units present in the polymer, if the count is 1000, the degree of polymerization also become 1000. Okay, so remember here not the type of monomers, it is number of monomers present in the polymer. So I will explain here. So for example, if you see, observe the first diagram. So this is a polymer which is made by one type of monomer. So only red type of balls continuously involved in polymerization process. So there is only one type of monomer is there. But if you count the how many number of monomers is there, you will get almost 55 monomers is there. So 55 same monomers is there, but number of monomers is 55. So degree of polymerization become 55. Okay, so if you observe the second one, there is a two types of monomers is red ball and blue ball. There is a two types of monomer is there, but these types are not considered as the degree of polymerization. You should count how many monomers number, how many monomers present in the polymer. If you count 1, 2, 3 like that, if you count, it will also give the 55. So that 55 is called degree of polymerization. So does 55 is called degree of polymerization. So this is the topic for today. So is plastic is polymers are good or bad to the environment, and what is polymerization, what is polymer, what is monomer. So what is the criteria for monomer to involve in polymerization process, and degree of polymerization we discussed here. Thank you for watching my channel. If you like my videos, please subscribe and suggest to your friends. Thank you very much. Bye.